Hey everyone. So today we're going to be talking about some common mistakes that people make when they're finding the derivative of a function. This is an area that a lot of people struggle with, and it's mostly because of two mistakes. They don't distribute their negatives properly, and they don't plug in the formula correctly. So we're going to go over some examples and show the correct way to do this, and try to give some tips for how to not do this. Okay, so first of all we have the definition of a derivative. So the definition goes, the derivative of some function f of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. So first of all, in this definition we have this negative sign, and this is one that causes a lot of trouble usually. So let's say we have this function f of x is equal to x squared plus 3x minus 2, and we want to find the derivative of it. So we plug it into our formula, say f prime of x is equal to the limit as h goes to 0 of x plus h squared plus 3 times x plus h minus 2. I'm going to put this negative sign in red. Minus x squared plus 3x minus 2. All this divided by h. Okay, so first of all, this setup is really important. These parentheses remind you that you do have to distribute this negative. So always write this part in parentheses. It's also good to write this in parentheses too, if you want. So this is going to be equal to, this part we have to FOIL this out, and we get x squared plus 2xh plus h squared plus this 3, we have to distribute this to both these terms as well. 3x plus 3h minus 2. Now this negative minus x squared, we have to bring it to the 3, minus 3x, we have to bring it to the 2, which would make it a plus 2. All this divided by h. Okay, now some awesome things happen. We have an x squared and we have a minus x squared, so this equals 0. We have a 3x and a minus 3x, so this equals 0. And we have a minus 2 and a plus 2, so this equals 0. Notice if we had not distributed these negatives correctly, none of these cancellations, except for the negative x squared and the x squared, would have canceled. We have a much more complicated function. So we're left with a 2xh plus h squared plus a 3h divided by h. We can now pull out one factor of h from everything on the top, and we're left with, keep forgetting to write my limits, h times 2x plus h plus 3 divided by h. Now these cancel, and we're left with the limit as h goes to 0 of 2x plus h plus 3. Since h is going to 0, this is going to just go away. So we're left with 2x plus 3 as our final answer. Okay? So this is the correct distributing of negatives. So now we're going to see what happens if we would not have distributed our negative correctly. So this part is still the same. Most people don't have a problem with this. X squared plus 2xh plus h squared plus 3x plus 3h. Some people have a problem distributing numbers as well, but negatives are usually more the problem. Now what most people would do in this situation would be just distribute it to the x squared and forget about these other two terms. So So if we did that, we get a much more complicated expression. This x squared cancels with this x squared, but this plus 3 just adds on to this plus 3. This minus 2, we subtract another 2, we end up with negative 4. So we end up with 2xh plus h squared plus 6x plus 3h minus 4 divided by h. And where do you go from here? Well, you can't pull out an h from everything, because we have this 6x and this minus 4, and you still have an h on the bottom, so you kind of don't know what to do next. So this is what happens with when you don't distribute a negative. You get a much more complicated expression, usually, and it's obviously not correct. So how can we avoid making these errors? So first of all, a lot of people make these mistakes and they try to ignore the fact that they made them, and they just like move on, they change it, and they say, okay, I won't do that on the exam. But the thing is, you probably will do it on the exam, and it's nothing to be ashamed of as long as you just try to grow from your mistakes. So I think it's a good strategy every time you make a mistake like this, just make a note in your notebook. Near your notes where this section is, say, oh, I tend to make this mistake on these type of problems. And you'll retrain yourself to not make these mistakes. So the second mistake that people make a lot is just plugging in the formula incorrectly. And this usually happens because it's on the exam and you're rushing through things and you just miss something. So a lot of people, especially when you have a polynomial with multiple terms, they'll just write the terms that have x's in them and they'll forget about the last ones. So, for example, you might write that this is x plus h squared plus 3 times x plus h, and then skip right ahead to the minus x squared plus 3x minus 2, and then divide by h. So you've forgotten this whole negative 2 term that needs to be in here. So that just comes from moving too fast, and I know you don't have a lot of time on the exams, but this is something that's very important. So my method for trying to not do this is to try to write the problem in the same order every time. So have some system for writing this problem. So I like to write the outline of the problem before I go anywhere. So that means, so we're always going to have this limit here. We're always going to have a term here minus another term divided by h. So let's go ahead and just write that. And we'll write it fairly large so that we have enough space for everything. So we have f prime of x is equal to the limit as h goes to 0. We're going to have an h on the bottom. Let's put a big pair of parentheses here, slightly smaller pair of parentheses over there. Actually, let's make that one bigger. There. So now we're going to write down the outline of this problem. So it's going to be something squared plus 3 times another something minus 2. And over here we just have our function directly. X squared plus 3x minus 2. Now we're going to go back and fill in these blanks. So these are supposed to be x plus h's, x plus h, and x plus h. So now, at this point, you should go back and just make sure that you did everything correctly. This actually is this function. We haven't missed any part before you start. And then you can just go ahead and start with the simplification. It takes about 2 seconds to just go back and look at your work again on the exam and just make sure you've set it up right. But that's something you should always do, especially with this problem. So everyone makes silly algebra mistakes from time to time, and the thing is that you really can learn a lot from them. So don't beat yourself up when you make a mistake. Everyone makes them. So what you really need to do is try not to ignore the mistakes that you're making. You really don't want to make a mistake and be like, oh, I'm just never going to do that again. Like, I won't do that on the exam. You might do that on the exam. So just accept that you made the mistake and write a note to yourself, write it down, and then when you're studying for the exam, study your mistakes. Really look back and be like, okay, I know on this kind of problem I tend to forget to distribute my negatives, I tend to write down the problem incorrectly, I tend to move too fast. Write down those, study those. And it will really retrain you to make less mistakes in the long haul. Another thing I've seen people doing is, so a lot of times when you make a mistake, you just sort of fix it in your own work. You go back and rather than redoing the problem again, you just sort of say, oh, well that would make this, and that would change this, and then I would get this answer. And then they plug that answer into WebAssign, but then they haven't actually worked the problem correctly completely. So it's really a good idea to just go back and do the problem again. I know it takes a little bit more time, but you will get more time practicing doing the correct process. That's all I have today. Good luck, guys.